Before Cassini reached Saturn's orbit in 2004, the cosmic dust analyzer on board detected a special kind of dust particle, stream particles, tiny particles which are ejected from the Saturnian system at high velocity. Because they are so small, once they become charged, they're very sensitive to electromagnetic forces and are ejected from the Saturnian system with speeds more than 100 kilometers per second. The source of the interplanetary magnetic field is the Sun. At the time of Cassini's arrival, the Sun's magnetic field was outward in the south and inward in the north. The solar wind and magnetic field fill all of interplanetary space, as shown in this depiction, with Saturn and Cassini at the outermost perimeter. The Sun's rotation winds the field up into a large spiral pattern. As this structure propagates radially outward from the Sun, it interacts with the Earth, Saturn, and all the planets of the solar system. High-speed solar wind runs into slower wind in front of it, forming regions of alternating high pressure, colored red, and low pressure, colored blue. The direction of the magnetic field reverses sign near the high pressure regions. In this depiction, the left panel shows the interplanetary magnetic field and solar wind velocity measured by other instruments on Cassini. The solar wind speed is shown in the top panel, the magnetic field strength in the middle panel, and the direction of the magnetic field at the bottom. Initially, the solar wind speed is variable but relatively low and the field is weak. Soon, however, around day 161, the solar wind speed increases abruptly and the magnetic field more than doubles. The direction of the field changes sign a few days later, day 163, as indicated in the lower left panel. This pattern repeats itself as the Sun rotates roughly every 27 days. As we rerun the animation, we call your attention to the sphere in the upper right corner, and particularly to the intermittent red bar that indicates the actual particle impacts measured by the cosmic dust analyzer. With a limited field of view, CDA can only cover part of the sky. Blue contours projected onto an imaginary sphere show where CDA was pointing. The green bar indicates the direction of stream particle impacts predicted from the model, and the red bar marks the direction of measured particle impacts. The center of the animation shows the simulated stream particle trajectories based on the measured Cassini solar wind velocity and interplanetary magnetic field. After being ejected from Saturn's magnetosphere and entering interplanetary space, the trajectories of stream particles are dominated by the solar wind magnetic field, as one can see that the shape of the dust sheet varies. First they are bent downward, then lifted quickly upward as Cassini passes through a high-pressure region, and the direction of the magnetic field reverses sign. During this period, many dust impacts are detected, as indicated by the numerous red bars, when CDA points southward toward the predicted direction of the Saturnian dust streams. As Cassini continues in orbit, the cosmic dust analyzer will continue to look for dust stream particles, unique messengers carrying information about the Saturnian system.